Okay, so at this point we have added polynomials, we have subtracted polynomials, we've multiplied polynomials. So the next logical thing to do would be to divide them, right? But division is kind of an actually complicated thing to do. Just think about the fact that we, most of the time that we're dividing, refer to long division as a thing that we have to do if we don't have a calculator that'll do it for us. And so part of the complication with dividing with numbers is that if it doesn't divide evenly, right, at first we learned to just write a remainder, and then maybe we learned to write it as a mixed number, and then when we started talking about decimals, we talked about how we can go ahead and actually like keep finding more things, and then either it stops or we have to round it and that sort of thing. So for polynomials, when we divide, there is a long division of polynomials that we'll do in Algebra 2. But for now, we're just going to talk about basically how do we split polynomials up into two things that multiply together to get that polynomial. In the same way that we could talk about splitting up these things I have listed here, the 24 and the x cubed. Okay, so if I use the word factor, I'm saying numbers that divide evenly or things that divide evenly into what I originally have. So factors of 24, I can list them as a list, or I can list them in pairs, which is what I like to do. So if I'm listing as pairs, factors of 24 could be like 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are the factors of 24 paired up with the things that actually multiply together to get us 24. So that's a thing that you have done before in some form or fashion. You've had to think at some point about what numbers go into a number that you're given. But now that we're in algebra, we're going to add some letters to this. And so if I ask, what are the factors of x cubed? Then that question becomes, how do I take x cubed, which is really x times x times x, and how do I split it up into two things that multiply to get x cubed? So for this one, there's really, if I want two things that multiply to get x cubed, there's basically only one option that I can say, well, I guess I can think of two actually. X times x squared would give me x cubed. I can write that in the opposite order if I want to, but that's still the same thing. Or I could write, and we have this on every single time we find factors, 1 times x cubed would also technically be a factor. So that's to introduce this idea of what we call factoring. When we factor polynomials, our goal is to take what we are starting with, which is a polynomial, and we're trying to split it up into two things that multiply to get that polynomial. This is actually going to basically be the reverse of what we did when we multiplied polynomials. So these examples, how they're written out would be like the answers to our multiplication problems. We're trying to work backwards and figure out what was the problem. There are a few different ways we factor. All of them are with the idea of splitting things up, but there's some different techniques we use. So the first technique, and the one that you should always look for on every single problem, is that we are going to learn how to factor out the greatest common factor. You should at some point before now in math have done greatest common factor, where you look at two numbers and you say, what's the biggest number that goes into both? And so that's what we're doing here, but we're also going to have x's involved. So on example A, if I look at each of these terms and I say, okay, what do these terms have in common between all three of them? Then I'm really looking at two separate questions. One is there a number that I can divide each one of these by? And then I'm also going to ask myself, do they all have an x, or do they all have a certain number of x's? Because if they all have an x, then they have that in common. They don't all have an x, but they do all seem to be divisible by 3. So That is our greatest common factor. The way we write this is we write a 3, and then we open parentheses, and inside the parentheses, we're going to put what is the result if I divide each of these terms by 3. So 6x squared divided by 3, you do the 6 divided by 3 to get 2x squared. 3x divided by 3 would be x. 9 divided by 3 would be 3. And so if we double check and say, okay, nothing in here has a common factor anymore, that means we took out the correct greatest common factor, and this would be our answer. See how this answer looks like what we did when we were using the distributive property to multiply polynomials. And in fact, if you wanted to check that you did it right, you could distribute, and what that does is you should get back to your original polynomial. So I'm going to do a few more of these here to hopefully address any issues that might come up. So on B, I look at these numbers 2, 5, and 10. Well, there's not actually a number in common other than 1. So then we look at the x's. X cubed, x squared, and x. They all have an x. And when we check for this, we want to make sure that we take out as many x's as we can. And the way we do that is by looking at the smallest number of x's, which is this one. There's only a single x there, which means that at most I can divide each of these by x. And that is our greatest common factor. So I'm going to write down what I can divide by, which is x. And then I'm going to go through and say, okay, 2x cubed divided by x. Well, this is why we went over, one of the reasons why we went over our exponent rules. X cubed over x to the first, and x would cancel out and leave us with x squared. And we still have that 2, so this would be 2x squared. 5x squared divided by x would be 5x. Because, you know, remember x squared is 2 of them and x is 1, so one of them cancels. 10x divided by x. Well, that just makes the x's go away completely and leaves us with plus 10. And then if we look through here and say, okay, have I actually taken out the greatest common factor, which I have because they don't all divide by the same thing, then this is my answer. So the first two only had, like the first one only had a number that came out, the second one had an x. Let's see what happens if we have both come out. So on this one, I look at the numbers and I say, okay, 12, 8, and 4. Those are all divisible by 2. That's not the biggest thing they're divisible by. They're all divided by 4. If you divide by 2 and work it out, that's fine as long as you're checking your answer to see if there's something else that you can take out again. So I'm going to use the 4 though. And then I'm also going to look and say, do they all have an x? And they all do. They all have at least one x because the last one, 4x, has a single x. All the single x, all the single x. Okay. So the greatest common factor is 4x. So we write that on the outside. And then on the inside, we're going to do what happens if you divide these by 4x. So 12 divided by 4 is 3. X cubed divided by x is x squared. When you divide by an x, you are taking away 1 from the exponent, in case that wasn't clear, if that's helpful information. So 8x squared divided by 4x. 8 divided by 4 is 2. X squared divided by x makes our x squared turn into x to the first, which we don't have to write the first part. Now, this is something that I wanted to have happen to make sure that I address it for you. 4x divided by 4x divides evenly, so that you'd be like, oh, it cancels out. But when you cancel out something like this, it still has a value of 1. Not 0, but 1. And one of the best ways that I can prove to you that that should be the case is by saying, well, distribute and think about how we would get back to this 4x. If I don't put anything here, or if I put 0 here, there's no way for me to get that 4x from, going backwards in my problem. So If it cancels out completely, just make sure that you put a +1 or a -1 so that it is correct. On this last one, I threw in some negatives here. There's kind of some weird rules about negatives that, like, I could technically take a negative out of this because 2 of them are in common, and it would change all 3 signs. But typically, we do one of 2 things in math. We only take out the negative if they're all negative, or we might take out a negative if the first thing is negative, because we like for the first thing to be positive when possible. It's just like a math thing that we like. So in this case, I would say don't take out the negative because the 8x to the 4th is positive and they're not all negative. What do they have in common? I can divide them all by 4. And this time my least number of x's is x squared. So I'm not going to divide just by x, because if I do, I will still have another x in common. So I'm going to divide each of them by 4x squared. That's what I'm going to write on the outside of my parentheses. And then that gives me, let's see, 8 divided by 4 is 2. X to the 4th divided by x squared, you subtract the exponents. 4 minus 2 is 2, so that's x squared. I need to make sure to put this minus sign. 12 divided by 4 is 3. X cubed divided by x squared is a single x. Then a minus sign, and 20x squared divided by 4x squared. The x squareds are going to cancel, and then 20 divided by 4 is 5. And that's what we're doing in this lesson. So practice, check your answers as you practice to make sure you're doing it right, and I'll see you in the next video.